For curve C, it is given to us by the question that you will be passing through the point with the coordinates -1, -4. So at the point -1, -4, x is going to be equal to -1 and y is going to be equal to -4. Let's substitute the two values into the equation. So it is going to be -4 is going to be a times of x, which is going to be -1 square, plus b times of -1 plus c over 3 times of -1 plus 1. This will give us our first equation, and that will be a minus b plus c is equal to 8. This is equation number 1. It is also given to us that it will be passing through another point, -3, -2, and this point is also a turning point. So let's make use of dy dx. Let's find dy dx for this first. So for this equation that is given to us for curve C, differentiating this will be 3x plus 1, then 2ax plus b. Then minus away ax squared plus bx plus c. Differentiating the denominator gives us a 3 divided by the denominator square. So 3x plus 1 squared. So according to the question, at the point -3, -2. Okay, so at this point, x is going to be equal to -3, y is going to be equal to -2. Let's substitute the two values into this, just like what we have done here first. So that will be -2 is equal to a times of x, which will be -3 squared, b times of -3 plus c over 3 times of -3 plus 1. This will give us our second equation, and this second equation will be 9a minus 3b plus c is equal to 16. So this is equation number 2. Our last equation that will help us to form a complete system of linear equation that can solve for a, b, c will be the fact that at the point -3, 2, it is a turning point. So dy dx is going to be equal to 0. So for this, we know that dy dx is going to be equal to 0. So it will be 3 times of -3 plus 1. Then here it will be 2a times of -3 plus b. Then minus away this will be a times of -3 squared plus b of -3 plus c. Then this multiplied by 3 divided by this, which actually doesn't really matter since it's in the denominator and we are going to be equating this to 0. So multiplying this over, this will just disappear. But still, let me just write down the values. This plus 1 squared. And this will give rise to our last equation, 21a plus b minus 3c is equal to 0. So this is equation number 3, solving 1, 2, 3 using our graphing calculator. So from our graphing calculator, we are going to be getting a as 1, b as 0, and c as 7. So this is part 1. Let's take a look at part 2. So for part 2, we are supposed to hence sketch the curve C. So for the curve C, the equation is now y is equal to a, which is 1. So we have an x squared, b is 0, and c is 7. So this divided by 3x plus 1. This is an improper rational expression. In order for us to be sketching this, we will be expecting a vertical asymptote, x is equal to -1/3, and we will be expecting an oblique asymptote. So for the oblique asymptote, let's try to do a long division of this to try to change this into a proper format. And doing a long division to this will be giving us a 1/3 x minus 1/9 plus 64 over 9 times of 3x plus 1. So the oblique asymptote is going to be y is equal to 1/3 x negative minus 1/9. So let's try to sketch this. We should try to sketch the asymptotes first, okay? So let me try to sketch in the axis, then the asymptotes. Then I'll use my graphing calculator and I'll complete the entire graph. So let me try to sketch a graph. So for my graph, the vertical asymptote is going to be x is equal to -1/3. The oblique asymptote will be y is equal to 1 over 3x minus 1 over 9. Let's quote this point. When x is equal to 0, this point here will be 0, 7. And let's also quote the minimum point here and the maximum point here. From the calculator, the minimum point here is 2.33 and 1.56. And the maximum point here is negative 1.97 and negative 2.22. And this is curve C.